In this problem, we're asked to evaluate the integral of 32x times x squared plus 1 to the 7th dx. This is a polynomial. In fact, it would be what? Degree 14 and 1 is 15 degree polynomial. And our goal is to find the set of functions basically that has this derivative. So we're anti-differentiating, and we have a couple of techniques for this. One is to just try and guess the antiderivative, which would be difficult. Try and guess what function has this antiderivative. If this was all multiplied out so that it was kind of in the standard form that we write polynomials in, something times x to a power plus something times x to a power, those pieces individually would be easy to anti-differentiate. So one possible approach here is to multiply this out. But that would take a while with that 7 there. So I think I would attempt to use substitution on this problem. And again, the idea with substitution is to pick some part of the problem that you can simplify by replacing it simply with a new variable, and u is the typical choice. So I'm going to choose u to be this interior piece, the x squared plus 1, and see where that leads me. If I'm successful, I should end up with a new integral, hopefully one that's so easy I can just write the answer down to. If this fails, I could come back and try something new, or eventually I guess multiply it all out if that's the only option that works. So in this case, if I let u be, this again is my choice, I'm going to let u equal x squared plus 1, then du is a calculation. You find the derivative of u, which in this case would be 2x plus 0, just 2x, and attach a dx. Alright, it's multiplication there. And now what I need to do is rebuild my integral in terms of those new variables. And part of this was easy, and basically when I'm done here I need to have no x's in here. Just I can have numbers and u's and du. So I need to change out all of the x's for something new. And part of this is easy. We selected this to be x squared, the x squared plus 1 to be u. So this x squared plus 1 to the 7th piece can get replaced by a u to the 7th. And so that's the first step I do, is replace the easy stuff. Then I check to see what's left over. What I have left over here is a 32 dx. And so the 32 dx needs to make its way back into my new integral, but I can't use x when I do that. I need to change to u's. So I go looking for the dx, which can be found right here, and see what more I can pick up with this. Can I get everything else? I want 32x dx, and I've got a 2x dx, so I do see a way to build this up. If I multiply this by 16, I will have 32x dx. So this is what we call a type 2. If you can just do a little bit of algebra on the du equation to get what you need, we call that type 2. And in this case, 16 du would have to be equal to, 16 du is equal to 32x dx. So the 32x dx that I had in the problem, I can now replace with a 16 and a du. And this now, I can find a simple way to anti-differentiate. I'll pull that 16 out of the way, antiderivative u to the 7th, and it's increase the exponent by 1, multiply by 1 over the new exponent, and we don't want to forget to add on our arbitrary constant. And then to finish this problem off, to get the value, the set of functions whose derivative is 32x times x squared plus 1 to the 7th, I need to clean this up and replace the u's by the original function of x squared plus 1. So 16 divided by 8 is 2, and instead of u to the 8th, we're going to write x squared plus 1 to the 8th. X squared plus 1 again is what u is equal to, and we don't want to forget our c. So this is what I believe is the answer to this problem. And to check my work on this, always a good idea. It's easy to check. You simply differentiate your answer and check to see that you get back from this the original integrand, the function that was in the integral to begin with. And when you do this, you should end up needing to do a chain rule. The derivative of the constant, first of all, is c, since it's added, or is 0, since it's simply added on. This 2 I can pull out of the way, and I'll chain rule here on the x squared plus 1 to the 8th. I'll bring the exponent down, leave what's inside alone, reduce the exponent by 1, and then find the derivative of the inside, multiply by that. So multiply by 2x. And notice the numbers that you see in your check are related to the numbers that we've used throughout the problem. So if I had made a mistake here, which I got to clean this up to see if I've got it right, but if I did make a mistake here, I can usually detect the mistake and track it back into the problem where that number was important and make a correction. Let's see how this works out. I've got 2 times 8 times 2, which is 32. I've got an x, and I've got an x squared plus 1 to the 7th, which is what I started with, so I know I got this one right. Guaranteed.